Hello everyone, welcome back to DataVidhyalaya. I am Suresh Reddy Nusi. In this video, we will be getting started with the Numpy library. Numpy library is which is a fundamental library, like where it will be used for the mathematical operations, scientific operations and all. It is mostly used in the areas of the data analysis, machine learning, and various other areas like deep learning and all. So we will be getting started with what is NumPy and why it is used in the numerical computations and all in Python and all. Okay. So first thing is that NumPy stands for numerical Python. So it is a fundamental library and also a open source library which is used for the numerical computations, like where we can execute the calculations in Python, uh, and it has it has a one of the important data type, like where we call it as arrays. Means like it's not a data type. It's where we call as a storage container, like arrays and all, where we can create an multi-dimensional arrays, like one dimensional array, two dimensional array, like that, multi-dimensional, like a n dimensional arrays and all. It supports to the large and collection of this mathematical functions, like where it will make this arrays computations, like operations, like different operations, mathematical operations, like addition, subtraction, multiplications and all, as well as this assignment operations, trigonometric operations, everything and all efficiently with the arrays. So as I said earlier, like it is used in the scientific calculations, data analysis, and machine learning, where if you wanted to create a synthetic data and all, and in the deep learning and all, where when we are working with the layers and all in the area of neural networks and all, it will be used more during that time. And NumPy is a fundamental library. Why? Because it is a foundation, like where when we are going through this data analysis or the machine learning, at any point of time, we'll be using this NumPy library. Okay. Once you start using that, touching up the use cases and all, implementing the business use cases and all, you will know the importance of this NumPy library. That's why it is good to learn this NumPy library. Okay. And why it is mostly used and all, because it gives the it is more efficient. Okay. And it is also a memory efficient, and mostly it is convenience for the uh, performing the mathematical operations and all. Okay. So efficiency in the sense, like it has been implemented, means like some of the operations it has been incorporated in C, where when we use these functions using this library, there in the back end it has the calculations uh, which they have written in C, where it has been combined with the Python and all, and implement those operations in C and get back the results into the Python and all. That's why it is somewhat faster compared to the traditional data types that we would like list, it, tuple and all. No, compared to that, it has more efficient. Why? Because it performs the operations in C language and again it provides the results into the Python. It is a memory efficient, is that it's the way of storing the data. So how it stores the data, that's why it is called a more efficient way compared to the list and all. Means like storing the data is different, no, that's why it is efficient and all. Convenience is like it provides a rich set of functions, like different, as I said, no, np, the sum, average, minimum, maximum, those aggregate operations, bitwise operations. It has the dimensional operations and all. Those all it perform. It has these capabilities. That's why it is called a we they may. here we mentioned it as a convenience and all. So why we can perform the operations directly instead of creating a explicitly when we are creating a loops like for loop and while do while loop and all, where we can perform the operations and directly in the way. Okay, by for example, if there are two arrays, no, we can directly perform the multiple operations instead of you pulling the first one first index ID and from the first array and second index ID from the first second index array and using the for loop and all. So these and all we will not be having. We can do the operations directly by multiplying these both arrays and all. So like that, that's why it is more convenient and all. Okay. So now let's get into the how we can install that and how we can import it. Okay. So mostly like if you wanted to install the NumPy into the Google Colab, like we will be using like exclamatory mark pip install NumPy. Okay. If you are running into the local environment, like your exclamatory will not be there. Just you will be using the pip install NumPy. Okay. As this is already installed in my library, I have just installed in the Google Colab. I am just commenting it by using the as mark. Okay. And then if you wanted to use this NumPy library, we need to import it. Okay. So how to import it? Like import NumPy as np. So we can directly use import NumPy. Okay. So as represents like it's a alias name. Alias name, like whenever we are calling a functions within a NumPy, instead of writing this NumPy dot some NumPy dot n dimension, NumPy dot shape and all. These are some of the functions within the NumPy library. Okay. So instead of calling the NumPy every time, now we can just use it as an alias name, which is like np. Okay. That's why we will be tagging this as np and all. So it makes the uh, code more efficient and easy way to write the uh, code and all. Okay. That's why we use that. So when we run this import NumPy as np, yeah, it has executed. So if you wanted to see the NumPy's version, okay, so what version has been installed in our Google Colab and all, no, we can use this command np dot underscore underscore version underscore underscore 2.0.2. Okay, so it's the version of the NumPy. So as I said earlier, NumPy is an open source library. Okay, as the community keeps on increasing, so they will be adding the multiple functions into that. Okay, or methods into that, which helps to overcome the issues between the versions and all. So for example, it started with the first version. Okay. As they keep on appending the new functions or new methods and all, and overcoming the issues in the first version and all, no, they will be creating another version like two, and they keep on updating with the different version. So if you are facing any issues with the versions or not, you keep updating the versions. Okay, so that you can overcome the issues and all. If there will be the new functions are added, the methods added in that, you can utilize when you are enhancing the library of the new versions. Okay, so that's the how we can install that, and then we can import that. So now we will start creating a one-dimensional array and two-dimensional array as well as the three-dimensional array. So first thing is that you you can create these NumPy arrays from the Python list tuples or sets and all using np.array function. So np is nothing but an NumPy library. Array is one of the function in it. Okay. So for example, creating a one-dimensional NumPy array. Okay. So I am just taking one of the variable name. So it's called array underscore one dimensional is equal to np. Np is nothing but numpy. Okay, numpy dot array means like you create an array. Okay, curved brackets. Within that we are passing one list. So if it is a squared bracket, no, we call it as a list. Okay. So what we are passing? We are passing a 1, 2, 3, 4, 5. Okay. So then we are printing that one dimensional array and then array ID. So yeah. So it's the one dimensional array. Okay. How it will be stored in the array in the sense like it stores in the by creating a if you see an Excel, no, Excel you will have like you will have different cells, no, in Excel, like it will form it like 1 2 3 4 5 like that it forms in the memory. Okay, so it will be stored in the form of cells like here it is like vertical, no, in the horizontal cells. Okay, sorry, in the vertical cells only, like 1 2 3 4 5 like that it stores in the memory of the how it stores the array and all. Okay, the same way we can in the next video I will show you how it stores and all. Why? Because you will get an idea like how the one dimensional array is stored in the memory when we use these numpy arrays. Okay, so the same way we can create a two-dimensional arrays. So two-dimensional arrays, let us assume that this is just a line, okay, as a one-dimensional array. So two-dimensional array will have the two list like where we will be creating. So let us take an array underscore 2d is equal to np dot array, create an array, curved brackets, okay, first overall list we are taking, and within that two list as it is a two-dimensional array, no, so 1 2 3 4 5 6. Okay, 1 2 3 is the first dimension, first row, 4 5 6 is the second row. Okay, so we will see that here. So two-dimensional array is like 1 2 3. So this is the first row, and this is the second row of three dimensions. Okay, sorry, three columns, two rows. Okay, so the same way with the three-dimensional array. So when it comes to three-dimensional array, it will be a different scenario. Like uh, we need to say like how many uh, combinations are there, like two types of, see if you see here, so creating a three-dimensional numpy, so it is bit complicated to understand from the three-dimensional array where it goes into the different areas and all. So as I wanted to stop it at the two-dimensional array, I just wanted to showcase how it works in the three-dimensional array and all. Okay, so for example, three-dimensional array, so array 3d np dot array. So first is the major one. Okay, major list which is of two things. Okay, let us assume here is the major one. Okay, and then for this we have one set of array which is two rows, three columns. Okay, and this is the another set of array which is, let us assume 2D arrays. Okay, so this is one set of 2D array, this is one set of 2D array. If we both combine the set of 2D arrays, no, it forms a it forms a 3D 3 dimensional array. So if you see here the shape of it, so two means like one, this is one, this is two. Okay, this 2 comma 3 is the two rows and three columns. Okay, so two rows in sense like 1 2 3 4 3 4 5 is the two rows. Okay, three columns is like 1 3 2 4 3 5 is the three columns, three columns here. Okay, two is the two sets of dimensions, like uh, this is one set, 1 2 3 4 4 5 3 4 5 is the one set, 5 6 7 7 8 9 is the another set. So like that it differentiates the two two dimensions. Okay, that's why two. and this 2 comma 3 in the second is the 2 rows and 3 columns. The same way, if so, to understand the one dimensional array, it will be very easy. Two dimensional also it's fine, but three dimensional there is some more uh, thing, means like additional value within the shape we need to identify. So we'll understand what is shape and all now. Okay, so in order to define the metadata of the array, like how what is an array and all, like what is the shape of it, what is the dimension of it, what is the data type of it, and what is the size of it, no? So these, in order to identify the metadata of an array, so we have these four attributes, okay, where we can use these four attributes, which will help us to understand what type of an array it is. Okay, so for example, uh, dot shape means like variable name dot shape. Shape is nothing but where it provides the dimensions of the array. How many rows are there? How many columns are there? Okay, and variable name dot dimensions, number of array dimensions, like what type of dimensions, like 1D array, 2D array, 3D array, 4D array, n dimensional array. So what is the dimensions? N dimensions. Dim means n dimension. Shape is nothing but the rows and columns. The first one will belongs to rows, the second one will belongs to the columns. And dtype, dtype means like what type of the element are stored in an array. Okay, that's the dtype and all. Okay, data type, dtype is nothing but a data type of the elements in an array. And size, what is the total number of elements, like what we call is like length in the list, no? That's how here we call it as an dot size. Size is nothing but the total number of elements in an array. So as we have created a three dimensional array, like one is a one dimensional array, the other one is two dimensional array, the third one is the three dimensional array. Okay, so we will see, like I have added the these four, like shape, n dimension, size, as well as the d type for the three dimensional array. We will see one by one. Okay, so if you see one dimensional array, the shape is 5, like 1, 2, 3, 4, 5. So 5 only rows are there, no? That's why it is making as like 5 comma. Columns are not there. Okay. So the shape of the one dimensional array is represented in this manner. It's a similar like a list and all. Okay. One dimensional array. And dimensions is 1, data type is int64, and total number of elements is 5. So one dimensional is easy, like we can understand it. So when it comes to two-dimensional array, no? So here we will have the shape as 2 rows and 3 columns. So if you see, yeah, this one, 1, 2, 3, 4, 5, 6. So 1, 2, 3 is one row, 4, 5, 6 is the second row. The 3 columns is 1, 4, 2, 5, 3, 6. So that's why 2 comma 3 is the shape of the two-dimensional array. And now what is the number of dimensions? Like it has a 2 dimensions. Okay, 2 comma 3, sorry, 2 dimensions. Okay, and 64 is the data, into 64 is the data type. Okay, as it has numerical arrays. Okay, so numerical values in the arrays. And total number of elements is like 6, means like total length of the numbers, means like which total length of the numbers in that particular array. So now coming to the three dimensional array, this shape you need to understand, like 2 comma 2 comma 3. Okay, so 2 comma 2 comma 3 is the, in the sense like first we are dividing that into two combinations. So this is one combination, and this is another combination. Okay, these are two set of uh, dimensions. Okay, and this one is the 2 comma 3 is the shape of the two dimensions within that. Okay, so this is one, let us assume this is one dimension, and this is the second dimension. Like 2 means like 2 rows, 3 columns, like this. How many are there? 2 are there. So that's the shape of it. Okay, sorry, that's the shape of it. Okay, and how many dimensions? Let here we have three dimensions. And what is the data type? Int 64 is the data type. What is the number of elements? We have 12 number of total elements. Like we have 6 in the first dimension, second in the second one we have 6. 6 plus 6, 12. That's how we find the total number of elements. So that's the those are the four attributes that which we will be using to define an array. Okay, define means like to understand the what type of array it is. Okay, regarding the shape of the array which defines the number of rows as well as the columns. Okay, and dimensions, and I mean what type of dimension, like it's a 1D 2D or 3D array, a dimensional array, and what is the data type with the elements in the array. Okay, that's we call it as a d type, dot d type function. Dot size is the total number of elements in the array. Okay, so that's about the attributes to identify the metadata, and how we can create using this np dot array function. Okay, which will help us to create an array. And those these the and this is the importance of the numpy. Like in the next we'll see the how we can do the operations. Okay, mathematical operations, and then how we can do the indexing and slicing and all those things and all we'll see in the next video. Thank you.